Bismillahirrahmanirrahim. Sallallahu alaihi wasallam. Allahumma rabbi zidni ilma. Sallallahu alaihi wasallam. Ameen. AS level T1. Today we will begin with binomial expansions. Lecture number 1. And the most important thing is concepts. Comprehensive concepts plus regular practice is equal to A star. Binomial expansions. In this chapter, you will learn how to expand the expansions of the form 1 plus b power n and a plus b whole power n, where n can be any positive integer. Expansions of these types are called binomial expansions. Binomial, the word binomial means two terms. And these are the examples of binomial expansion questions. You will see in the first question, the first term is 1. In the second and third example, the first term is not 1. Combinations. We use combinations in binomial theorem. There are some rules regarding the combinations which will make the calculation simple. For example, if we have 5c0, the answer is always 1. If we have this number 0, the answer will always be 1. If we have same numbers like 5 and 5, the answer will always be 1. If we have 1 here, then answer will be this number, like in this formula. See, we have same numbers here, the answer is always 1. When we have 0 here, answer is always 1. So these are very important combination rules which will make your calculation fast. Combination rules in factorial form. We need these rules when we have to work for the power of the expansion. When the power of the expansion is unknown, then we use these rules to get the value of n. Well, nc1 can be written as n upon 1 factorial. Since we have 1 here, therefore we should write this number here 1 factorial, means they both are same numbers. Like we have 2 here, so we must have 2 factorial. Since we have 3 here, so write 3 factorial here. Now let's talk about the numerator. Since we have 1 here, so we must have only one term in the numerator. Since we have 2 here, therefore we must have 2 terms in the numerator, n and n minus 1, and they must be in descending order. Like first is n and the next should be n minus 1. As we have 3 here in denominator, this number 3, so we must have 3 terms in the numerator and they must be in descending order, and so on. Now binomial expansions of 1 plus b power n and 1 minus b power n. So let's talk about the first expansion, 1 plus b power n. If you see the first term in both the expansion, the first term in both the expansion is 1. So this theorem is used when the first term of the expansion is 1. So for 1 plus bn, when we have plus sign here, then all sign must be positive. And this is the binomial theorem when the first term is 1. It's 1 plus nc1 times b power 1. This number, this power must be the same number like this number. Since we have 2 here, so this must be 2. The power of the second number is always the number which is in combination here. So when we have negative sign between the terms, then the signs are alternate. See, we have negative here, therefore signs must be in alternate way. First sign is plus, then minus, then plus, then minus, and so on. Note, use the above expansions and or theorems when the first term of the expansion is 1. If the first term of the expansion is not 1, then don't use these theorems. Example, obtain the first 3 terms in the expansion of. Since the first term of this expansion is 1, therefore we will use the second form of the theorem, this one, 1 minus b power n here. So because of this negative sign, the signs must be alternate. The signs are alternate. So you just need to substitute the values into this theorem carefully. Make sure you do not consider the sign of second term here and here. So while using the theorem, while using the combination form, like theorem in fact, never consider the sign of the second term. The second term is negative 2x, but you just need to write 2x here, because you already have managed this sign, negative sign here. Because of this negative sign, the signs are alternate. So never take the sign of the second term while using the theorem. I have mentioned this note here. Never take the negative sign of the second term while using the theorem. Now let's discuss the binomial expansions of a plus b and a minus b power n. Since the first term is not 1, therefore we have to consider the first term in the theorem. So this is the theorem with plus sign, and this is the theorem with negative sign. So when we have plus sign here, then all signs are positive. And you can learn this theorem in this way: nc1. So if you subtract these two numbers, n and 1, then this will become the power of first term. And the power of the second term will always be this number. Like we have 2 here. See, the power of the second term is 2. And the difference of these two numbers is the power of the first term. When we have negative sign in the expansion between the terms, then signs must be alternate. And the rest of the things are same. Use these two theorems to expand the expansions of all types. Now the question is, obtain the first 3 terms in the expansion of. Since the first term is not 1 here, therefore we will use this second form of the theorem, this form in this question. So because of this negative sign, the signs must be alternate. And you just need to substitute everything carefully. Be careful while writing the second term. Never take the sign of the second term while using the theorem. Just write plus 3x square here, plus 3x square here. Now just simplify everything and you will get the answer. The answer is 1024 minus 15360 x power 2 plus 103680 x power 4 and so on. We had to find only first 3 terms, therefore just write dots here. Now let's discuss the nth term formula. The nth term formula can be made by using the theorem. If you see the second term, if you look at the second term, this term, and carefully, so if we replace this one and this one, in fact all ones, if we replace all ones of the second term by r, then we will get this Tn formula. See, if we will replace this one by r, we will get NCR, n minus r and r. This is the way to make the formula of the nth term. So this is very simple. You can easily make the formula. You don't need to learn this formula. You can make this formula by replacing 1, 1 and 1. All these 3 ones by r. And this capital N is r plus 1. This means r is less than 1. Is 1 less than n. That is, small r is 1 less than the capital N. Now, where do we use this formula? The Tn or Tr plus 1 formula is used to find the indicated or particular or specific term or terms without expanding the expansions. For T7, R should be 6 because R is always 1 less than with respect to N. So if this is 7, then R must be 1 less. I have mentioned this here. R is 1 less than N. If R is 10, then N must be 11 because N is always 1 more than R. Therefore, you need to work for T11. Make sure you take the sign of the second term. This is very important. you must take the sign of the second term while using the Tn formula. Make sure you take the second term with its sign, means with negative sign, while using the Tn formula. For example, in this question, we need the independent of x. We have to find the term which is independent of x. Independent of x means the constant term, that is x power 0 in the expansion of. Well, the second term has negative sign, so make sure you will take this sign. We will solve this question by a Tn formula because we need a specific term. Here we have n9, small n is 9, a is x, the first term, b is minus 5 upon x square, the second term, and r is unknown. So for r, we use the Tn formula. We just need to substitute everything in the Tn formula for like n, a, b. Make sure this is negative. So when you will substitute everything in this formula except r, just call this equation as equation number 1. Now consider only x from equation 1. You need to consider this x and this x. So just consider x from equation 1. So from this bracket you will get x power 9 minus r, and from this bracket you will get 1 upon x square power r. Now just get the simplified form of these two x. You know, when same bases multiply, then we add the powers. So this is the simplified form of the x. Now equate this x with the requirement. And what is the requirement? The requirement is x power 0, the term independent of x, to get the value of r. So here we equated both and we got r3. So as soon as you get the value of r, substitute r back into equation number 1. This was equation number 1. So I substituted r here, here, and here. Now just get the simplified form. So this is the answer of the term which is independent of x. Now this is the tip of the class. Be fair with everyone. Inshallah, we will discuss the other concepts of binomial theorem in the next lecture. Wassalamu alaikum wa rahmatullahi wa barakatuh. Allah Hafiz.